Exercise 9.3. A hydrogen atom is excited by radiation of wavelength 97.5 nanometer. Find the principal quantum number of the excited state. Show that the number of lines in the emission spectrum is n into n minus 1 by 2. Compute the total number of possible lines in emission spectrum. Okay. Now what is given here is the lambda value is given. So that is 97.5 nanometer. So we can write it as 97.5 into 10 raised to minus 9 meter. Okay. Now we have to find out the principal quantum number of the excited state. Okay. So first we'll go for finding the energy of the excited state. Okay. So energy of excited state E is equal to what? H nu. So that is Hc by lambda. So you know the value of Planck's constant, that is 6.626 into 10 raised to minus 34 into C value is velocity of light, that is 3 into 10 raised to 8 divided by lambda value is 97.5 into 10 raised to minus 9. Okay. Now if you multiply these things, you will be getting it as 19.878 into 10 raised to minus 16 divided by 975. This is in joules. So in order to convert it into electron volt, we can write 19.878 into 10 raised to minus 16 divided by 975. In order to convert it into electron volt, you have to divide it by 1.6 into 10 raised to minus 90. Now your answer will be in electron volt. Okay. So this is 19.878 divided by 1560 into 10 raised to 7 electron volt. This is 10 raised to 3 electron volt. So if you divide this, you will be getting it as 1.274 into 10 raised to minus 2 into 10 raised to 3 electron volt. So that is 12.74 electron volts. Now this is a hydrogen atom. So we know the energy of the hydrogen atom in ground state. So energy in ground state is minus 13.6 electron volt. This we already know. Okay. So now what is the total energy here? En is equal to minus 13.6 plus 12.74. So what is the energy? Minus 0.86 electron volt. We know En is equal to minus 13.6 by n square electron volt. Okay, so n square is equal to minus 13.6 by En into electron volt. So this can be written as minus 13.6 by, we have found out the En value as minus 0.86. Okay, so both are in electron volt, so the electron volt will get cancelled. So 13.6 divided by 0.86 will be getting as 16. So n square is equal to 16, n is equal to what? 4. So the principal quantum number is, so n is the principal quantum number. So principal quantum number is what? N is equal to 4. Okay. Now, the second part of the question. So the total number of lines in emission spectrum. That is n into n minus 1 by 2. N into n minus 1 by 2. So what you can write? 4 into 4 minus 1 by 2. So it is 4 into 3 by 2, which is equal to what? 6. Okay. So how many transitions are possible? 6 transitions are possible. Now we can represent this in the diagram. Here the energy levels, here it is n is equal to 1, n is equal to 2, n is equal to 3 and n is equal to 4. The values are minus 13.6 electron volt. Here this is minus 3.4 electron volt, minus 1.57 electron volt and minus 0.85 electron volt. Now we have to put the possible transitions. Okay, so the transitions are possible between, the first one is between the first excited level and the ground state. This is possible. Okay. Then from second excited state to the ground state, then the third excited state to the ground state. These are possible. Similarly, from third n is equal to 3 to n is equal to 2 is possible. That is second excited state to first excited state. Similarly, what? Third excited state to first excited state is also possible. Similarly, between third and second is also possible. So here how many transitions are possible? 6 transitions are possible.